Welcome to VTeach. In this section, we are going to discuss about common collector configuration. In last session, we have discussed about the common emitter configuration and common base configuration. So here we are going to see the common collector configuration. Before going to start the any configuration, first take the code that is West Engineering College and as well as left to right. Now here we are going to take for the common collector. So make this is a ground. Then from left to right, B is becoming the input terminal and E is emitter is becoming the output terminal. So here you can see that the input voltage for the common collector configuration is input voltage is VBC and input current is IPC. And as well as you can see here that output voltage for the common collector configuration is VEC and IEC is a current. Now you can see here it is the configuration in which the collector is common between emitter and base. Here the collector is a common between the base and as well as the emitter is known as common collector configuration. In CC configuration, the input circuit is connected between the emitter and base. The input circuit is connected between the, you can see here it is. So here it is input. You can take here it is a input and as well as this side it is a out. So this side it is a output. You can see the collector is common to both the input and output circuit and hence the name common collector connection or common collector configuration. So here the emitter, you can see here that emitter is connected here and as well as base is here and collector is connected as a common and output we are taking from the emitter to collector and input we are giving from the base to collector. So that's why it is in input side and this side it is in output side. And now you can see that the current amplification factor, every configuration is having the current amplification factor including alpha, beta, gamma. We can say that for the common emitter configuration we are getting the alpha and for the common base configuration we are getting alpha. For the common emitter configuration we are getting beta. For the common collector configuration we are having the gamma. So here all the alpha and beta and gamma all are current factors, output current by input current. So here the current amplification factor is depend as the ratio of the output current to the input current. You can see here the output current for the common collector configuration is emitter and as well as the input current for the common collector configuration is base current. So in common emitter configuration, the output current is emitter current IE, whereas the input current is IB. Thus, the ratio changes of the emitter current to the change in the base current is known as like this. So gamma equal to change in emitter current by change in base current, which is called as the output current by input current. Now we can find out the relation between the gamma and as well as the beta and as well as the alpha. Now here you can see that you can get the relation between the gamma and beta here. So gamma means it is the change in output current by change in input current and as well as you can see here it is a alpha is a change in output current. For the alpha is happening in the common base configuration. So for the common base configuration output current is a emitter current and as well as the here it is the input current is IB. You can see here it is the main thing here IE equal to IC plus IB, collector current plus base current. So del IE equal to del IC by del IB here because change in output current by change in current you can call here it is the change in collector current, change in base current that equal to the change in emitter current. This is the basic formula, emitter current equal to collector current plus base current. Here we can take that del IB equal to del IC minus IC. From the above equations we can write down that. So now you can see that alpha equal to, so here alpha equal to del I by del IB. So here you can see the del IC by del IB. Here we are having the del I value and as well as we are having the del IB value. Then if you are substituting like this, then it is becoming del IB by del IE by del IB. Now we are writing that del IB value. Then after that, if you are dividing with the del IE, then it is becoming like this. And finally, this is the relation between alpha and as well as the gamma. So gamma equal to 1 by 1 minus alpha. After derivation this one, you can get that alpha equal to 1 by 1 minus alpha. The above relation shows that the current, that the value of the gamma is nearly equal to the beta and this is known mainly used for the amplification because this arrangement input resistance is high, the output resistance is the low. The voltage gain of resistance is very low here. So, and this circuit arrangement is mainly used for the impedance matching. Actually, common collector configuration is used for the impedance matching. So whenever you are connected some circuit to the another circuit, in between we need to make impedance matching. At that time we can use the common collector configuration, and as well as the common collector configuration is having the high current gain and low voltage gain. If you are coming for the common base configuration, there we are having the high voltage gain and as well as the unity current gain. Here in common collector configuration we are having the unity voltage gain and high current gain. Now we will see and as well as how we can draw the input characteristics of the common collector and output characteristics of the common collector. The input characteristics of the common collector configuration is drawn between the input voltage and input current. And as well as from the starting onwards, we are saying that the input characteristics, whenever you are going to draw the input characteristics, at the time output should be a constant. Whenever you are going to draw the output characteristics, at the time input should be a constant. So here, so we are going to draw the input characteristics. At that time, you can see that the output voltage should be a constant. So here, IB is a input current and VCB is a input voltage. If I am drawing the input voltage and input current graph, whenever I am going to draw at that time, if I am making that VC is a constant, at that time we are getting graph. If you are changing the output voltage according to that, here also it will be changed. And previously we have seen that in the common base and common emitter configuration, it is becoming like this. Even though it may be in the common base and common emitter, it is happening like this. But if you are seeing in the common collector configuration, it is going like this, somewhat backward it is happening. So like that, if you can draw the output characteristics, whenever you are going to draw the output characteristics, at that time input current should be a constant, and output characteristics we can draw in between the output voltage and output current. So here the output voltage is a VCE voltage, VCE, that is in terms of voltage, and as well as the IE, it is in the milliamps. And we know that compared to the IE, IB, IC, IB value is very less and IE value is the greater than the IB and IC. So that's why, so whenever you are drawing the input characteristics, which we call it is the base element, at that time we are having the microamperes, which is less current it is having. If you are coming for the output current, which we can call it is the emitter current, at that time we are having the milliamperes. So you can see here also IB is having the less value and as well as the IE is having the more values. So like that, if you are drawing the output characteristics in between the output voltage and output current, input current should be a constant. If you are changing the input current according to that, the graph is going to be changed. And we know that left side it is called as a saturation region, and this is active region, and bottom below the zero what we are having, that is called as a cutoff region. So the transistor operates in active region when the base current increases and reaches to a saturation region. The graph is plotted by the keeping the base current IB. Base current IB is constant and the varying the emitter collector voltage VC. So whenever you are keeping the IB is the constant, if I am changing the VC according to that, IE will be changed. If you can draw the graph like this, then it will look like this. If you are changing the constant value, IB value from the 10 micro to 20 micro, according to that, it will be changed. The graph you can changes in graph you can find out in the diagram itself. The values of the output current IE are noticed with respect to the VCE. By using the VCE and IE at constant IB, the output characteristics curve is drawn. So here you can see, so we can draw the output characteristics for all the configurations, CB configuration, CE configuration and CC configuration. The CC configuration, especially it is having the impedance matching, especially this is used for the impedance matching, and it is having the high current gain compared to the CB and CE. The CC is having the high current gain, and as well as there is one drawback is there in the common collector configuration. It is having the less voltage gain. We can say that it is less than the unity, and as well as it is having the high current gain because it is output current is a IE and as well as the input current is IB. So that's why the gamma is having the higher value, that is a IE by IB. Thank you.